Yeah, sure. Okay, so for some of you, the things we're going to cover today might be repetitive, might be something that you're already familiar with. So, but I still invite you to bear with me and continue this session, being present in this session. So I expect you all have your laptops ready. For the course, we're gonna be relying on Jupyter Notebook mainly and some Python libraries. So I'm gonna have them here, Pandas and Python. Yeah, we're gonna use Pandas, we're gonna use NumPy. So these are two of the main libraries that we're gonna use, okay? And to use them, we're gonna take advantage of another tool called Jupyter Notebook. Okay, this fella here. So there are actually multiple ways for you to use Jupyter Notebook, but let's put it this way. I can do some drawing here, yeah? And you can see my drawing, yeah? Can you confirm if you can see my drawing? Yeah, okay. What? Yeah, you can see. Okay. So, the point is, Python, this is your processor, this is your computer. Python runs here. So every time you run a code, your code is written here, your code goes there, it turns into zeros and one, and then it's get executed, okay? But Jupyter Notebook gives you an environment which is always active. You don't have to like run it as a code each time you're using the notebook. So it's constantly running and lets you run the code in cells, okay? So to use Jupyter, you can either install it directly on your system. You can use a tool called, how can I remove these? Okay, yes. Okay, so yeah, clear all the time. Okay. You can either install it directly on your system. You can either use it within a platform called Anaconda, which we're gonna install together, or you can use it on Google Colab. Okay, so this is this address here, colab.research.google.com, which lets you to run Jupyter Notebooks on cloud. Like Google technically gives you resources to run the codes, okay? If you have VS Code installed on your system, you can have it on VS Code, okay? Just so you can see it here. This is a Jupyter Notebook that we have. Okay, these are the examples we're gonna go through together, okay? So, if you want to use Conda, I suggest you to install Miniconda, so you can come to this link. Let me just copy and paste it here for you all. Okay. So what you can do is that you can install Miniconda. I have a M2 MacBook Air here, so I'm gonna install the Apple Silicon version. But going to the link that I have put here for you, I'm gonna also put it in on Discord under additional resources. Okay, so I'm gonna install it here. There is a very simple installation wizard. Okay. Good thing about installing Miniconda is that you won't have to install libraries and worry about like updating packages, because Anaconda has everything installed within its platform. And I suggest you to install Miniconda, because Miniconda is a smaller version of Anaconda. Anaconda has like way more tools and packages which you can use, but for now we don't need them. Maybe in the future for your next assignments you might need some of them, but for now we won't need them. Okay, this is one way of doing it. So let's wait until it gets installed. If you want to use it on Google Colab, okay, you simply come here, and whatever notebook you have on your system, you can just upload them. You can even import them from GitHub, or you can directly upload them from your system. So let's say I have an example here for today's lab. I can just drag and drop it here, and it just opens it for myself. Okay, so the Conda is also installed. So okay, I'm gonna close this one. So first of all, I'm gonna show you. Faiz says, would you also be able to share the Discord server link here? Might have missed it somewhere. Yeah, sure. Just give me a minute. Give me a second. I'm gonna have it here. Okay. Okay. Invite the server. Okay, I put the link in the chat. Okay, so let's see, let's open. You're welcome, guys. Okay. So okay, I think it's installed. So graphical installation. Okay, let me just put this on Discord too. Additional resources. Okay, so if I open my terminal here, where is my terminal? That's here. I have to. Okay, so if I list it here, you can see that Conda is installed, and we have all of these packages and libraries is installed within Conda. Okay, so let's see how we can open Jupyter Notebook using Conda here. Let's see if it's already installed here. We can install any new packages using this command here. Okay. So, okay. Okay, now it's installed, and I can say Jupyter Notebook open, and here we are. Okay, on your system using Conda. If you install Conda on your Windows, you will have a graphical interface. On Mac, we are also supposed to have a graphical interface, but I couldn't find it. Okay, so if the terminal thing is really new to you and you don't know how to use this, don't fret, because you will have a graphical interface. I have put the link to installation on Discord. But if you open Jupyter Notebook on your system, it actually opens as a page on a browser. Okay, so either on Google Colab or on your system, you have it as a tab in your on your browser. Okay, so here, let's say we have some examples here under the downloads. Okay, and oops. And I have week 1 here, so okay, I can open the notebook here. This is one way of doing it. Okay, and I just have to wait for it to load. Okay, so this is the notebook. Some of you who have already passed the data visualization course, you are already familiar with observable, okay? Where when we were using observable, we had cells in which we could run code, okay? Jupyter Notebook has the same idea. So in these cells, you can run a code, okay? And next to the each cell, we have a number here. This number indicates it's a counter that shows the number of the last cell being executed. Okay, so this is the second time that I've tried to run this, and I'm receiving an error. Here, I'm getting this error telling me that I don't have any module named NumPy. Okay, so this error stems from the fact that apparently we haven't installed NumPy, but we already told you that installing Anaconda, you have all the libraries and packages available. So what you have to do is to choose the kernel here. Okay, this kernel means using the Python kernel that Jupyter Notebook uses to run the codes and the lines. Okay, so I can here choose the kernel. Okay, I'm saying to use this here. Okay, let me, I must be able to, let me see, this shouldn't be like this. Okay, before I fix this, because it was working fine on my system, but I had removed Conda to show you the installation, so I'm not quite sure where it's coming from. But I can show you how it's supposed to work here on Google Colab. So on Colab, all packages are already available on Google Cloud. So if you run any of the cells, it connects to the system that you have here, and you can import this package right away. Okay. There is also another way of running packages, which is using virtual environments in Python. I'm thinking maybe explaining the virtual environment might be a bit complex for this class. So let me ask this question. Have you worked with virtual environments before in Python? Just type yes or no in the chat. Yes, yes, yes. Okay, cool. Nerds, yeah, nerds. Okay, yes, 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 no. All right, since most of you already know how to work with virtual environments, I'm just gonna point this out, and later, for those of you who don't know how to work with virtual environments, we are going to either publish another video or give you a link on how to do it. So what you can do is that on VS Code you can also open Jupyter Notebook. Okay, so if you have VS Code on your system, you technically don't need to install Jupyter Notebook again. What you need to do here is to, instead of installing all packages and everything you need universally on your system, you create a separate environment from which you run every Python code that you have. So I'm gonna just show it here. Okay, so let's say here I am in the folder where my codes are. Okay, so you can see the Jupyter Notebooks that I have here, and if I want to show you the folder right away here to you guys, so this is it. Okay, this is what we have here. I'm gonna delete this. Okay, what you can do is that you can run a simple command, and you tell your system. It's easier to do it on Mac, but you can follow the same steps on Windows. You ask Python to create a virtual environment within that folder. You see we have this folder here, and you can activate it by entering this command. Oops. Okay, so here, whatever Python code that you're gonna use, whichever Python code you're gonna run is gonna use the packages that are available within this virtual environment. Okay, so here, if I want to, let's say, run this cell, okay, I can tell VS Code to use this kernel here, this virtual environment here, to run the codes here. Okay, this is another way of doing it. If you're not familiar with the virtual environments, we're going to explain it later. Anyways, so you have 3 ways of doing it. I personally suggest using Google Colab, but make sure to, for each of your assignments, make sure to create a separate, you can actually create a single repository under which you can upload each of your assignments, okay? And put the final version of notebooks there, okay? Don't rely on sharing the link only. So, can we submit assignments on GitHub? Yeah, Atif, that's what we're gonna basically do, because we don't have Canvas, and most of it is gonna be coding. So I'm gonna put the instruction on the course GitHub page, but what you're gonna do is you create a repository with folders, and under each folder you're gonna upload whatever code or report or video or whatever you have for that assignments, and you put them there. This way we can also track the time of your last commit, okay, to make sure that you have done everything before the deadline, because we don't have Canvas to keep track of things. Yeah, thank you so much. Anyways, okay, let's go around and see what NumPy can do for us. So there are, okay, Mina Hill has asked if we are using Colab, we'll download the notebook and then upload it to GitHub. Yes, Mina Hill. Yeah, that's exactly what we're gonna do. So you download it and you then upload it on a repository. Okay. You always, okay, okay, sure. So this is a reminder for you all. Yeah, we need to be able to run your code, your Jupyter Notebooks on our own system. So before uploading, make sure that it also runs on your system. You also have this option here to save a copy of each notebook on GitHub. And if you click on it, you will be transferred to a authorizing page, so where you can create a new repository and do the stuff here. Okay, so I'm just gonna cancel it right now. Okay, for those of you who are not familiar with NumPy, NumPy is actually giving you tons of features to work with data and data sets. Okay, so what we know from Python is that, can we access today's notebooks? Yeah, they are actually up on our GitHub. Let me just share the link with you on Discord. Like the codes themselves, they're not that complex. I'm just going to show you some examples. Additional resources. I'm going to put it under lecture slides. So lab 1 codes can be found here. What I encourage you to do is to have notebook available on your system, either via Colab or locally on your system. And if you haven't worked with these tools before, this is an opportunity to like get your heads around them. Okay, because it'll be much easier for you to do the basics here and to do the advanced by yourself. So yeah, that's why we are technically having this lab. Otherwise, you can find everything that I'm explaining here on multiple different resources, including DataCamp. Actually, the examples that I'm gonna telling you come from this NumPy cheat sheet that I'm putting here. But the gist is in doing it together. Okay. So before we proceed, for those of you who haven't worked with NumPy or Jupyter Notebook before, do all of you have it running on your systems right now? Because some of you have already done this before, but those of you who don't have any experience, I want to make sure that it was clear how to set up things for you. Okay, we have one positive feedback. Okay, that's cool. That's cool. So one thing that you can do is that, similar to simple Python codes, simple Python lists, you can also create lists with NumPy. The difference is when you want to tweak these lists. Okay, so further, we may not be able to cover them on this lab, during this lab, but I'm definitely going to show you the difference between tweaking lists and working with lists and doing computational procedures on lists using for loops or while loops compared to using NumPy. But we can create any kind of list here, so I'm gonna do this here. Oops. And when I run it, I can run each cell by pressing Shift and Enter. We can define a list here. We can do the same for a two-dimension list. Let's tweak it a bit and see what happens. So when we have a two-dimension list, make sure that all lists have the same number of elements. Okay, so boom, we have it here. More importantly, these are like really small data sets. They have a few items in them. But when you're working with like huge data sets, you want to be able to get a quick grasp of their shape and their attributes. Okay, give me a second. I have a message on Discord from one of the students. Okay. Okay. So let's. I'm sorry. I was answering another student on Discord. So yeah, here we have a really small data set. However, when we're working with like huge data sets and multi-dimensional data sets, it's important to have the attributes here. Okay, so here this is a let's tweak with this list and see what happens. So if we add to the items, okay, let's see what happens when we do this. Okay, so this changes the answer, the number of the rows and the columns changes. So if we make it look like this, okay, so here it shows the dimensions. Okay, so it says we have 2 lists, each of them have 3 lists within them, and each of those lists have 5 items within them. Okay, so it's a 3-dimensional list, and it goes on and on and on. Okay, so let's say if you have like 5-dimensional, you can see it here, and you can, by entering this number of dimensions command here, you can skip what we have here. Ali Reza Kardini, yes, you have raised the hand. Yeah, sure. Thank you for pointing this out. Yeah, like when you work with these words for a long time, you tend to forget the differences. But yeah, this is actually a quite important difference that we have here. In Python, we have lists, but here we have arrays, and this difference in naming actually comes from the nature of the objects that we have here. These objects are way easier to work with and to do computational to do computations on them compared to the ordinary lists. So as we were going, another attribute of each array here is the size of it. Okay, so here we know this is a three-dimensional array, and to update the size, it has three elements in total, which quite makes sense. If we multiply these dimensions, 2 and 3 and 5 results in 30. We have 30 elements here. So if you have worked with matrices, you know that there is a function called transpose. So it technically changes the position of the columns and rows in a matrix. Which is a really useful function that we have in matrices. We can do it here using this. Okay, so let's look at the original. Okay, so yeah, this is the original array we had here. 1, 2, 3, 4, 5, 4, 5, 6. So it's technically, let's make it simpler so that we better understand the transpose being run here, because some of you might have forgotten what transpose was. Okay, so we have 3 rows and 5 columns. The dimension changes, the size changes, and yeah, so this is the transpose of the original array. Okay, so it was originally 1, 2, 3, 4, 5, 4, 5, 6, 7, 8, 5, 7, 8, 12, 13, and it's been transposed to this. In some cases, we want to have all the elements next to each other without the 2-dimensional or 3-dimensional representation, and we can use a flat command here. Okay, so this turns the array into a, technically it turns it into a list. Okay, and we can access each list and we can print them next to each other. This notebook is taken from Marek Hatala's course, which was taught last year during summer. You can find more examples here on DataCamp, and I suggest you to do so after the lab is over, because you're going to have a very small assignments after the lab is finished. We can actually go over more examples, but I find them a bit repetitive, and some of them are actually common and shared with Pandas. So we're going to switch to Pandas, and we're going to create a new notebook to take a look at what Pandas can do for us. Okay. So let's change the name to Pandas. Do you have any questions so far? No? Okay. Cool. So for these examples that I'm gonna work through on for Pandas, there's also a famous data set which is called field consumption, and I'm just gonna show you a quick peek of it. Give me a second. Field consumption. Okay. So this is a CSV data set, where I'm not working with the exact data set here, but the examples that I have were inspired by this. Each row represents a car model, the year, the make, the model, the class, engine size, cylinders, transmissions, fuel type, etc. here Pandas is going to help us to use some tools to create a data set similar to that, a similar data set to that, and see what Pandas can do for us. So let's start with importing our libraries. So first of all, I'm gonna import Pandas as PD, and I'm gonna import NumPy as NP. Okay, so we have them ready here. Okay, let's start with some car. I want to have an array. Okay, so give me some models. Yeah. Mustafa asks how to run these libraries in Google Colab. So I just show you how you do them. You just enter the Python command here, and you just click on this or press shift and enter. Okay, cool. Atif says Cadillac, escalate. We need a few more suggestions, so if you have any favorite car models, you can type it in the chat so we can fill out the array. Lexus, okay, Lexus. I personally like Chevrolet. Okay, what else? Dodge. Okay, Audi, Dodge. Okay, Audi. We have Dodge. We have Ram. We have Porsche. Okay. Okay, I'm not sure what that is, but Morning Kia, is it Kia Morning, or is it like all together as a car model? It's interesting. I haven't heard it before. Anyways, so we have an array here. We have a bunch of car models here, products, and we also want to have an array of months. Okay, so January, February, March, April, May, June, okay, we have all the months: January, February, March, April, May, June. Let's fix the naming here. July, August. Okay. So we want to have an imaginary array of monthly sale of each of these products for each month for 6 years. Okay. This is just something imaginary that I have prepared before. Okay, so I'm gonna create a two-dimensional array here. These numbers are like, okay, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6. Okay, we need to, okay, add to this. Two, 3, 4, 5, 6, 7, 8, 9, 10, and okay. So let's make sure Okay, here we come here. We want to see what was it was the array. Okay, right, so we say print product shape. Okay, 10, and we want to have print sales data dot shape. Okay, so this also has 10 lists. So for each of these cars, we have the number of sales, the amount of sales for each month. What we're gonna do, we want to put these two together. Okay, we want to bind them together so that we have a, let's say, something similar to a CSV comma separated vector list. Okay, Pandas helps us to do that. Okay, so we can create a data frame with Pandas. Okay, what we have to do, I'm gonna name this data frame. We're gonna call Pandas, and we're gonna ask Pandas to create us a new data frame. Okay, so we're gonna call, let's say, okay, we're gonna use our data frame is this. Okay, so we're gonna have sales data as the first argument. Then the index is products. Okay, so each, I'm gonna put an S here. Okay, so each row is gonna be one product, and the columns would be months. Okay. Okay. So when I run this, okay, so you see this error here. That's because the last time we run this cell, we ran this cell, the name of the array here was product. So we have to run this again, and you see the number changes here. This is the last cell that's been executed, and when we run this here, we see that it works. So we currently have our data frame. We want to see what's happening within this data frame, so we're gonna print it. Let's see what happens if we print it. Okay, data frame. So here we have a beautiful data frame. Okay, point is, imagine we had, yeah, index technically means row, Atif. It's not exactly rows, but here it technically means rows. Yeah, cool. So the point is here, let's say instead of 10 data points, we had 1,000 data points. Okay, if we run this command here, it's gonna print all 100 rows of the data frames, and we don't want to do that. So what we're going to do when we are working with a really huge data set or data frame is that we only want to see a first few rows to have a basic understanding of what's happening within that data set. So we're going to print it, but this time we're going to call the head of it. Okay, so this method returns the first few rows, and voila, we have the first 5 rows of the data sets. Okay, so this is important because you start working with a data frame that you have no idea about, and you want to see the first few rows to see what fields you have and how it can work with it. So this is a really useful tool and command. So now, and one other thing that usually happens is that we want to see what's happening within a single column. So here we have different months. Okay, we want to do some operations, some calculations on a specific column. To do that, we can do something similar to two-dimensional lists in Python. I'm sorry, it's more similar to a dictionary where you call a key and you have all the values that are attributed to that key. So I'm interested to know more about the amount of sales near Christmas. So I'm gonna say, hey, what's been happening? I'm sorry, this is wrong. Okay, so here we have a beautiful representation of the data set for a single column, and here it also shows me the data type. It says that this column data type is integer and 64 bits. Okay. So for an index, for each index, we know the value for a specific column. Okay. If we want this in a less fancy format, we can do something like this. Yeah. So if you have, let's say, if you have like huge tons of data rows here, you can just simply choose to have multiple options here, multiple rows here. Okay. This was a bit more fancy. It was a bit fancier, but if you want it to be less fancy, you can do this. December to rain. Okay. Search. Okay. Let's continue with having the, like, we fixed a single column and looked at all the rows. Now we want to do the opposite. We want to fix a row and see all the data points there. Okay. So for that, we have this. Let's say, what car model we have here? We have Lexus. We're going to choose Lexus. We're going to come here. Okay. So again, for Lexus, it gives all the amounts that we have for the amount of sales of Lexus for each month. Similarly, if we want to, this LOC loc stands for locate, okay? If we want to have a specific data point here, okay, we can give both coordinates. So, data frame, excuse me, that's loc. So this time we want to see what's been happening during summer, and for Dodge. Okay, so here it returns 27. Okay. Let's say we want to have, we want to slice the data frame. Okay, we want to have some rows and some columns. Okay, so we can add to these coordinates we're giving to this method here. So we're gonna call data frame. We're gonna call locate, but this time we have multi-dimensional location. So here I wanna know about Chevrolet and RAM, and from January to April. January to April. Okay, so see, it has chosen these two rows and these two columns. Okay, this is a data frame. Okay, any questions so far? Okay. No. Okay. Okay. So what if we don't want a specific rows and columns and we want to do actually slicing here? In Python, you might be familiar with this notation. Let's say we have a list. 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we say print, this returns the first 3 elements of the list, and this returns first, second, third, and fourth. So 1 and before 5. Here we do the same thing. Instead of specifying the exact columns and rows, we're gonna do the slicing. So we're gonna still use locate, but instead we're gonna say, okay, give me everything from Chevrolet to RAM. What's the problem? Oops. Okay, so here we see Chevrolet, Audi, Dodge, Ram, and similarly, if I copy this, and January 2. Excuse me, why isn't it working? Do I have to remove these? Maybe I have a syntax error. Yeah, so if we want to do slicing, we do this here. Okay, so if you have if you want a subset of the data frame, you can do this. Okay, here we see how we can tweak the data frame to see different parts of the data frame. What if we wanted to actually do some arithmetic conditioning here? So I'm interested in the cars that have sold more than 25K in January. Okay, so for doing so, we're gonna, let's say, new data frame. We're gonna create a new data frame based on the original one. Okay, so we're gonna say it's gonna be a data frame where data frame in January is bigger than 25. So let's take a moment to understand what we're doing here. Okay, so we say we have a data frame here. Pandas is so generous that it has enabled us to embed a conditional clause here. Okay, so here we say we want a part of this data frame which satisfies this condition. Okay, and we don't have to like have a really big if clause. We can simply say I want those data sets where if I, like for each row, if I take their amount of sale in January, it must be over 25. So this is one of the great things that Pandas let us do, because it shrinks the syntax necessary for this sort of calculations. Okay, so we create this here. It's created. We don't have any error. And then we can call it, print it here. So here we have 3 products whose January sale was over 25K. If we change this condition to let's 20 and run this again, we can see we have more cars. If we change this to 29, we can see only 2 cars satisfy this condition. So this is a really cool feature that Pandas let us do. We can like again, Pandas is again generous to let us combine these conditions within a single clause. So you know that if we have a single if clause here, we can say, let's say a larger than 25 and b larger than 30. Okay, this is something we can do in Python. Okay, same thing applies here. So again, we define a new data frame, and which is built using the original data frame, and the condition here is that in January it has a sale over 22, and I'm sorry, we have to separate these using parentheses. And in, let's say, I don't know, October, it's over 24. And then we run it and we see we don't have any error. So if we print it, we can see we have these cars here. Okay, so we check the October, all of them are over 30. Okay, let's say, let's put this to 34. We expect to see a change here. We see the change here. If we want to have them less than 30, okay, we don't have anything here because apparently, let's see, October. This is an interesting case. Okay, none of the cars satisfied this condition where their January sale is over 22 and their October is less than 30. Okay. Okay. Another thing to keep in mind is that this is another useful feature that Pandas is providing for us, because normally if you have a database, let's say you have a SQL database, you have like really huge queries, SQL queries to obtain the same results. But Pandas does it for us with a simple line of Python code. Okay, this is actually the genius in Pandas, the creativity that they've had. Okay, let's proceed with another thing we can do with Pandas. Do you have any questions so far, guys? Another question is, are you awake? Because I've been kind of talking in a monotone tone. Yeah, cool. Okay, yes, Atif, sure. We're gonna do this too. Yeah, we're gonna do this too. I can actually skip a bit and perform actions on. Okay, and you've also asked a bit tricky question because we wanted to let you do the same thing for your like mini assignment that you're gonna do after the lab, but I'm just gonna show you a quick peek of it. Yeah. No, I'm gonna show it. I'm gonna show it. No worries. Yeah. Okay, so I'm gonna let's take 5 minutes. Let's take 5 minutes. I'm gonna drink a bit of water and fill up my bottle. I'm gonna be back in 5 minutes because we've already passed more than an hour and 10 minutes. And we will be here until 7:20. Yeah. Thank you so much, man. Okay. Okay, so I'm gonna have a sip of it. Okay. So where were we? To answer Tiff's question, I can actually do it right away. What's this? Okay. So here we have some, and it's interesting. I didn't know that we have these sample data here on Google Colab. I just wanted to upload what we had here. I can actually do it too, yeah. So we have this fuel consumption. Okay. So here we have this fuel consumption CO2, okay? And we want to open them using Pandas and CSV. So we have FDF which stands for Field Data Frame, and we're going to say Panda, go and read CSV, and I have a file here called fuel consumption CO2.csv. I'm going to put it in quotation. And here we see that it runs. So here we have learned that instead of printing all of the data set, here we can just use the head. Where was the head? Here, the head. Okay, so I'm gonna say, okay, from FDF, print the head. Okay, and here we have this fellow here. Yes, Adriza? FDF that head. Yeah, I sometimes forget things are easier on Jupyter itself instead of running like bare commands. Yeah, thank you so much. Yeah, so you can see that we have the whole fuel consumption data set here, and we have the first five rows. So from now on, we can actually work with this data set here for some of the commands that we're going to see, but so this is how we do it. Okay, so whatever CSV file that you have, this is as simple as you can see here. If you are running Jupyter Notebook locally on your system, all you need to do is to have the CSV file in the same directory where your Jupyter Notebook is, okay? Even if it's not in the same directory, you just need to enter the relative path or full path, and that's going to be it. Okay, so another thing that we can do with Pandas is that we can re-index the data frame that we have. Sometimes our data set is not explicit, it's not informative, so we want to re-index and have new labels and have new rows, let's say. So we need to come up with a new list of cars. So please be generous in the chat and enter some of the car models that you like so much here. I'm thinking about RAV4. I'm thinking about BMW. I'm thinking about, okay, yeah, that was Kia Morning, not Morning Kia. Mercedes, yeah. Kia, okay. What else? Honda, yeah. I'm gonna say Skoda. Skoda. I'm gonna say BYD. I'm gonna say Camry, yeah. How many so far? 1, 2, 3, 4, 5, 6, 7, 8. We need 2 more. Tesla. Yeah. Tesla and something cherry. Okay, we have 10 more. So here, I'm not gonna write data frame, so I'm gonna write df new, and I'm gonna say, okay, do you remember we had a data frame before? Guess what? I'm gonna put a new order on it. Sorry, what's happening? Okay. Reindex. Yeah, I'm gonna reindex it. Okay, so it's done. And we can see df new here. Why is it like this? Df, let's print it and see what happens. Df new. Interesting. It shouldn't be like this. What's happening here? Well, let me see. Well, I just wanted to change the label of the rows, but apparently it's also messed with the data in the data frame, which isn't something that I was expecting based on the previous time that I ran this example. Okay, let's see what's up with the data frame itself. Okay, so data frame itself is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Why can't, what's the problem with this? Reindex. Okay, let me Pandas reindex documentation. Okay. Previous and new pages, previous only the new instance to the current and copy. Okay, let's. Try what? Yeah, I was thinking about the same thing. So after we've done it, we can say, you mean calling it here? Okay. Df new equals what? Set axis. Yeah. Okay. Axis equals index. Like this. Okay, and what about now? Oh, cool. So what was the problem? Yeah, I think the same thing. Okay, maybe I had to do this, or maybe this. Okay, I'm gonna check this later, but lesson learned. Okay. Anyways, so we have assigned new labels to the rows here. Okay. Okay, what else can we do? Okay, we can do some CRUD, like removing rows from the dataset that we have. It's pretty much straightforward. Well, all we need to do is to use drop, okay, and we can specify a specific row here. Drop, no, not Dutch. It has to be Honda. Honda. Okay, so when Honda is dropped, we can see that Honda isn't here anymore. Okay. Oh, you mean if it's okay? Yeah, I got it. No, it actually, yeah. Yeah. I actually, I was gonna, that was actually the next command that I wanted to say. That I want to say, if they want to remove something for good, they have to add the end place. So let's say if we want to like have it entirely gone from the original variable that we have here, because data frame here is a variable. If we want it gone, we can say, let's say byd and end place paragraph equals to true. Okay, df new, and when we have df new here, we see that there is no sign of byd here whatsoever. Yeah, and thank you for reminding me then. Okay, so let's get to the and more interesting part. So it's been just like wrangling the data set, like removing rows, watching it, exploring it. Okay, let me put it this way. We have a variable here. This is called dfnew. Okay, it consists of the array we see here. Okay, when we call drop method here, okay, it creates a new object, okay, that is the same data array without a specific row, okay, but it doesn't change the df underscore new variable itself. Okay, that's why when I executed this command on this table, we didn't see Honda, but afterwards, when we checked what was in this data frame, Honda was still there. Okay, but when you add this tag here, this flag here, and place true, this method doesn't create a new variable and show it here. It changes the df underscore new variable itself. Okay, so here what we see is a copy, is a temporary copy of df new. It's not df new itself, this is a copy, but here when in place equals true is given, this is df new itself, where we don't have byd anymore. Okay, yeah. Exactly. So if you wanted to have a new version of the data frame where we don't have Honda, you should have like put something here, let's say df, this is not a good naming, but df new is df new. So where were we? So yeah, when I run this here, df new still has Honda, but if I put it to df new, we don't have Honda here. Okay, And here, if I run this again, it returns an error and says I don't have any key here. I don't have any key called BYD here. It's not in the access, and it totally makes sense because we have already removed it from the data frame. Okay. Okay, so let's go for some arithmetic. So let's say if we want to, again, this is also a really powerful tool that Pandas gives us. Let's say if you want to add a constant value to each of the data points here, we can simply say print df new plus 10. So you can see that I can even omit the print here. See? So each field here is added 10. Okay, it's 18, it's 28, 26, 16. Okay, this is as simple as you can see here. Or we can multiply all the values too. Again, here we see a copy of dfnew. So if I run dfnew again, the data frame itself is still the same. So what we see here is a copy of it. Okay. We can do the same thing by multiplying everything in a constant amount. So dfnew multiplied by 1.1, and we have decimal numbers here, decimal values here. Okay. What we can do is we can have an average. We can define a monthly average and say, give me the dfnew print monthly average. Okay, so for each month we can see the average. Okay, and we can see how each of these columns perform compared to the average. So we say df difference is equal to dfnew minus monthly average. And we can see it here. Okay, so we can see how each of these cars have performed compared to the average. Okay. Okay, so same thing can be done using other methods like adding, subtracting, multiplying, dividing, etc. And let's see how it's done. Give me a second. Okay, so here we have two data frames. One of them is data frame, the other is dfnew. Yeah, okay, so let's say we want to add these two together. Okay, so let's see what happens if we say data frame plus dfnew. Okay, so here we have like a hellish table with all the fields being not assigned, and we can also see that rows have been put together. Okay, I want to check this out. I want to see what happens when we add two data frames that have that have the same indices. So I'm gonna create something, data frame 2 equals data frame multiplied by 101. Okay, and let's see how this looks. Okay, so this new data frame has the same indices, but the values are different. So I would like to see what happens when we add data frame to, just out of curiosity. Cool. Here, what we see is really interesting. We see when these two data frames share the same indices and share the same columns, they can be added together with like no problem. Okay. But we had a problem where indices weren't equal. So yeah, sure, Adriza, take care. Take care and good night. Good night. We are also wrapping up the lab in 10 minutes or so. So here, instead, we can have a df result and say, okay, I want to add another data frame to a data frame that I already have, which is, I've called it df new, but let's do this. Wherever, if you have a missing value in each of these data frames, okay, before you add it, treat it as a 0, okay? Because let's say df new has none of these indices. So when Pandas is trying to add these two together, he goes and searches in df new for Chevrolet and sees there is no variable under the index Chevrolet. So instead of assigning 0 to that value, it assigns not assigned object to that. And when you add a number to a not assigned, the result is a not assigned. But here we're saying, don't worry about the values that we don't have. Just put a 0 instead of them and do the addition. And if we check it, we see, hey, we have the data frame here, and Pandas has taken care of all of the missing items here. Okay? Same thing can be applied to subtraction and multiplication. So let's say here, if we do this, we see these numbers here, okay? And similarly, we can say, hey, subtract them. And you can see in data frame, those fields, all of the fields are intact because nothing has been subtracted from them. All the variables were equal to 0, like Cadillac here is 23. And if we come here, Cadillac is 23 too, okay? And on the other hand, every data point that's coming from df new has a minus value, which makes sense. Like here we have Tesla. If we go to Tesla somewhere here, where's Tesla? Yeah, 33, 36.3. Oh, no, this is it. Yeah, 30, 33, 35. And if we come here, we see the same thing. Where's Tesla? Minus 30, minus 33, minus 35, okay? So that's the way Pandas takes care of arithmetic functions. Last thing I would like to show you is applying functions. So these are like operators adding, subtraction, multiplication and stuff. Sometimes you would like to apply a function to each of the fields or each of the rows or each of the columns. It's not that different. You can either use a built-in function, you can use a user-defined function, or even a lambda function. If you don't know what lambda function is, don't fret. You're going to learn it sooner or later. But we have already seen that we can have the mean here. Let me see where we had it. Yeah, so we had the mean here, okay? One way of doing it is this, okay? The other way of doing it is to, let me create another cell. Copy cell. Okay, I wanted to have a cell there, but no worries. Instead of using Pandas mean function, I'm gonna use another function to calculate the average. Okay, so here I'm gonna say to this data frame, apply this function that I'm giving to you. Where does this function coming from? It's coming from NumPy. So NumPy already has a mean function here. So you're going to use it, Pandas. Instead of using your own functions, you're going to be using this. And we can see that this is the same thing as if we do it here. Let me bring this here. Put this here. Monthly average. See? 21.666, 23.222. And let's say for the last example, let's say if we have a user-defined function. Okay, so we want to define a range function which takes a number, and what it returns is it actually takes a list. Okay, so if we want to say df new range is equal to df new, hey Pandas, go and apply this function that I have defined here and apply it to each row. This means apply it to each row, okay? And if I have it here, okay, so we can see that the difference between maximum and minimum amount in each row, and we can actually technically check it here. So for RAV4, yeah, RAV4 here. Where is it? RAV4. So this is here. So the minimum amount is 20 here, and the maximum is 35, and it totally makes sense that we have a 15 here. Okay, and so on and so forth. Okay. So these are the basic things that you can do with Pandas and with NumPy. Pandas is really powerful when it comes to wrangling the data sets, having different parts of it, and NumPy is really powerful when you want to do arithmetic and calculations and stuff. And you're gonna have a really short assignment for this week, which I'm gonna show you, and I'm gonna upload it on GitHub, and we're gonna email it to you, okay, on what you're gonna do. But it's gonna be really easy, okay? I'm gonna just show you what we are expecting. One part of your exercise is something that we haven't covered in the lab, and that's because we want to encourage you to go and see what else you can do. So you will be working with a really famous data set, which is Titanic, the passengers on Titanic. You're going to do a bit of data exploration. You're going to be doing a bit of indexing and selection. You've seen these. We've already done them. You're going to do filtering, which we have already done. You're going to do reindexing and dropping, which we have already shown you. Arithmetic and data alignment. Okay, you're going to do some arithmetic. This might be a bit challenging. And the next two parts, part 7 is totally new. Part 6 is kind of new, and we don't expect it to take like more than 90 minutes or so for you. So we're gonna put it on GitHub. You're gonna do it, and you're gonna upload it to GitHub, and we're gonna explain how you do it specifically. Just have it on the back of your mind that the due date is a Friday night. Okay, you can even do it like by tomorrow night, but I don't want to be presumptuous, so you have until Friday night. If you have any questions regarding what we have done so far, you can bring them up now. If you don't have much of, are we able to get all files that you're working today? Yes, Jan. I've actually put them on GitHub, and I also think that I've already put the link on Discord. Yeah, I believe that I've put them under additional resources. Am I having hard time installing Anaconda due to system compatibility? Can I stick to Colab for everything using libraries like Pandas, NumPy, and is there anything? Okay, technically Colab, the point is Colab can do much more, and we want to make sure that without having those tools, you can run the Jupyter Notebook on your own device, okay? So if you have a problem installing Conda, one thing that you can do is to, instead of installing the minimal version, you install the full version where you also have the graphical interface. Or you can use Jupyter Notebook with VS Code. Even if you don't have Pandas, you can use Jupyter Notebook using VS Code. You have these two options, and if you're facing any specific errors, you can send me a message on Discord, because we currently have Discord for communications, or you can send me an email, including this file as well. Yes, Hasrat. Hasrat, I hope that I've pronounced it correctly. And if you find it challenging, and if you don't have any prior experience working with Python and you find all of these challenging, feel free to ask questions. And what we want to... I actually used Google Colab because I had removed Conda from my system to show you how we can install it. So I was unable to set the kernel here on Jupyter Notebook. However, I have it here on VS Code. Okay, I have it on VS Code, and Jupyter Notebook works pretty much fine here on VS Code. Okay, so you can see it here. So I can import NumPy, I can run this cell, we can have this two-dimensional. Yeah. Like as Ali Reza said in the beginning of the lab, you can work with Google Colab. We have introduced it so you can use it, but make sure that you try your Jupyter Notebook on your own device at least once before submitting, because we want to be able to run it on our systems too. Yeah, anyways, I was saying, if you have any problem with Python or coding, or if you found these challenging, you can reach out to us. We can introduce you some resources. More importantly, try to have fun with it, because as you know, most of the things that we do here, you can ask AI to do all of these, but we want you to have a fundamental understanding of what's happening under the hood, even if you're using AI or any like advanced tools you're using for your work. Okay? Any more questions? You're welcome, everyone. So Monday is a holiday. On Tuesday, you're gonna have a lecture, most probably on Tuesday, and we see each other soon. Take care. Bye bye. Take care. Take care. Have a good night. Thank you, Atif. Okay. Stop share. Tuesday, he does okay with me.